And then I will share my screen. And then we'll get started here. Hello, everyone. And welcome to this slightly more advanced tutorial on Git and GitHub. My sort of assumption is that folks who are here have used Git in some capacity. But I'll really start with some basics and go quickly from there. My goal is, at the end of this session, my goal is that you will be comfortable using GitHub to collaborate with each other and with me on code. And hopefully by the end of this tutorial, we will set up a project on GitHub that, for those of you who were in the Python libraries session just previously, we'll take one of these kind of Python projects and put it on GitHub in a way that GitHub will automatically check things with it and do some automated things there and set it up for collaboration using Git and GitHub. So if you're familiar with Git a little bit, you know that it's a version control system. And so Git provides for you a way to track your work within a directory. We call that part of your file system that we call a repository also, and allows you to track the state of that repository. Particular files within that repository that you designate are tracked over time. Their state over time is retained inside of the repository so that you can go back and forth in time to previous states of certain files and look at them. And that provides for you a way to track what has changed over time. But the way I think about Git is primarily the tool for collaborating. Because if you're tracking code and somebody else is tracking the same code, now you can share with each other things that you change in the code. And if you buy into this idea and use Git for everything and GitHub for all of your collaboration or systems similar to GitHub, then now a lot of modes of collaboration open up for you. Takes a little while to learn that, but once you do learn it, now a lot of things become standard across a lot of the work that you will do with computational things. And if you're like me, you'll end up just wanting to use Git and GitHub for everything, whether it's code or writing papers or writing slide presentations. Everything will end up in Git and GitHub for you, and using the same language and the same kind of framework to be thinking about a lot of your computational work. So that's to convince you that the effort required in order to learn this stuff is worth it. It gets a little confusing, but hopefully we'll clear some of that confusion today. And hopefully some of the confusion is clear today. You'll be using it next week to collaborate with each other, and then the rest of the confusion will be cleared up. And by next week, you'll be ready to adopt it into your regular workflow. Let me close a lot of things here that I had open from previously. Okay. So I'm going to start here with some pretty simple and initial things that we always have to do on every new computer that we're working with Git. This first part will be a thing that you do once every time that you start working with Git. Git, if you're already using Git a little bit, you're probably familiar with Git as a language. The way that Git works is that there is the application Git. And if you just type Git, it'll show you this help document that confirms that you have Git right there and it's working. The way that Git works is that it has subcommands. You type Git and then you type one of these additional words, and that allows you to issue certain operations in the repository in which you're working or just on your file system. And then subcommands have their own subcommands, and it can get very complicated and long. But that's the main way that we interact with Git is through the command line in that way. One of the subcommands is git config. Here's the help documentation for git config. The first thing that we'll want to configure, and I suggest you follow along because I'll actually be throwing some exercises to you later, and you'll want to do that. Follow along here so that you have things set up for you to use also in following days. I'm going to configure at the global level my user name, and I put my name in there, and I will want to git config. Whoops. My email address, and that's necessary. If you don't do those things, the first time you try to do something with Git, it will complain that you haven't done this. And the reason is everything that you do is attached to your name and email. So operations that you're doing, like commits that you're doing in a repository, get attached to your name and email. So it complains if you don't do those two steps. We will also configure at the global level core.editor, and we'll configure that to nano. The reason to do that is that the default setting here in the hub is for the editor that GitHub uses, that Git uses to be Vim, and I don't know how to use that, and so I don't want to do that. But if you enjoy Vim or VI, then don't do that. But if you're not, then, and this is what I'll use as nano, is a simple, relatively simple, straightforward text editor. Having done this configuration, we are now happy and we can start using it here on our machine. However, there is one more step of configuration that we'd like to do before we get started with all the rest of it, and that is to configure our interaction with GitHub. And GitHub has a very particular way of doing securely interacting with its users. In contrast to many websites, which will ask you for your username and a password, but really the most kind of stable way to interact with GitHub is through the provisioning of so-called SSH keys. So you'll want to produce SSH keys that will be stored on this machine, and then you'll want to tell GitHub about the key that you have stored on this machine in a way such that when you're operating against GitHub and it wants to authenticate you, it can perform a handshake operation between what it knows and what you have, and confirm that you are who you claim to be, and then everything will go smoothly from there. So in order to do that, I will point you to this page, which I will put in Slack now in this channel. So first go to this page and do the operations that are said there. And then, that first page will, the first page I posted there is going to generate the SSH key locally in your little part of in your home directory on the Jupyter Hub. And then this second link is all about adding your SSH key to your account on GitHub. So you need to go and tell GitHub, hey, I got this new SSH key that I would like to serve as an authenticator that I am who I claim to be. So let's take a few minutes into those two things. I've already done them, set them up on my corner of the hub. So I won't demonstrate doing this in detail, but let's do that on your end, so that things further down the line will go smooth. And let me know if you get stuck with anything. Just raise your hand or Slack me and we'll get you unstuck. I don't know, do I want the GitHub app on Slack? Maybe not.
Sorry, just to confirm, are we doing this in the terminal on Jupyter Notebook, or are we doing this on our machine?
In Jupyter Hub, so that we can all work in the same environment. Yes, in Jupyter Hub. In order to get a terminal in Jupyter Hub, you click on this big plus here and then choose terminal, and that will open a terminal window for you.
Should we save it in a different area, or do we all have our own?
You all have your own home directory. Your home directories, your view of the hub is isolated from everyone else. It's confusing because if I do CD and PWD, you all see exactly the same thing, which is home Jovian, but it's in isolated little containers.
Okay, cool.
Yeah, so you're all if you type who am I, you will all see Jovian, which are the people who live on Jupiter, so that makes sense. Inhabitants of Jupiter.
Is it a Docker?
Yeah, it's Dockerized into these little containers, yes. It's the infrastructure underlying this I can tell you a lot more about is Docker running on a Kubernetes cluster on Google's cloud. So it's turtles all the way down. Thanks, Max. I realized immediately what I was doing. Thanks.
It seems like some of the commands that they're suggesting, like open or pbcopy, you don't have access on.
Yes, pbcopy won't work. So okay, yeah, that's one. Ooh, I'll have to change my keys after I do this. I was hoping to avoid this, but I'll do that because I'm going to put this video up and I don't want to show my keys to the world. So yeah, this is going to end up in a folder called SSH, and the public part of your key is in here. less.ssh IDED pop. This is the part that you need to paste into GitHub. So you copy this thing, and that's the thing that goes into that GitHub text box. Well, I think technically my public key is only dangerous if somebody tries to pretend to be GitHub or something, right? Someone know? I think the private part is the private part. Public I've given to GitHub already. So maybe it's not crucial that I change my key.
I don't think we should do that because.
Here to the question how to generate this ED25519. It's SSH keygen -T ED. So no, not what I meant to do at all. Like that, yeah. Hopefully that answers the question. If you've completed that, you can put a thumbs up in there in Slack. That would be great. Just so I get a sense for whether I should wait a little longer. Okay, I'm gonna start slowly moving ahead here. I've seen several there, so I'll start slowly here and then you'll catch up. So the first thing that I'll do here is create a new directory with the project where we'll be working. This will be the repository we'll work, and we'll call it, trying to think of a new name that I haven't used before because I want to create a new GitHub repo. I'll call it GeoBlobs. It's as good a name as any, and it's new, so that's good. And then I'm changing my working directory into this directory using CD. So mkdir creates the directory, and then CD changes my working directory into this new directory. And then I will immediately initialize the Git repository in here. And Git warns me that it's named the branch that I'm using. Master. Oh, and am I in the right place? I don't know why it's not showing me the name of the branch, but it's saying, no, well, you might want to use some other name. One that's often used is main. So I'm going to go ahead and use main here. And I believe I'm probably on main here. You might not be telling me because I haven't made any commits yet. So we'll see what happens after I make some commits here. The main is also commonly used on GitHub, so that's one that you'll see a lot. So, and you can configure that even to be the thing that happens per default on your machine. So this adds to the configuration, the possibility to just, whenever you start a new repository, that the first branch that gets created into which you get dropped is called main. Who here has used branches in Git? Okay, quite a few. Okay, so you're familiar with this. The idea behind branches is it's a state of your repository that is attached to a tag, a name, not a tag, a name, a particular name. In this case, the particular name that this state of the repository is called is main. And that name will go along as you make commits. That name will go along and be associated with the head as long as you don't switch to another branch. That's a bit technical. The idea is you can have different states of your repository that you can switch back and forth between very rapidly by issuing the command git checkout. So git checkout branch name will switch everything in your directory that you're working on from one state to another state. And that's useful, as we'll see in just a minute, if you want to collaborate with others and still retain a pristine state of your main directory. But right now there's nothing here, so I'm going to add some stuff first into the repository and get it going off the ground. I'll actually use the code that I wrote in the previous session that was about Python libraries. I'll make this a Python library. So copy geometry. Let me copy the README file in here. I needed to give it the reason it issued that error is that when I copied, I didn't tell it where I'm going to copy that. And when I put that dot there, it said, put this README file right here in this directory. So now I have README in there. Let's start with that. That's a pretty good start. Git status is the command we type to say, what is the situation right now? What it usually will say is which branch we're sitting on. And then it will say various things about the state of the repository. Right now, it's telling us that there's one untracked file called readme.md. Git add readme.md tells Git that we want to track this file. So now instead of being untracked files, that one is a new file that's in changes to be committed. This part of the repository, this part of the status is something we also call the staging area. This is all the changes that will go into a subsequent commit. Git commit -m with a message then does adds this into the string of commits that we get in our repository. And now we're back to this Git status. This is the best status to be in because you're on branch main. There's nothing to commit, working tree clean, as in you're ready to call it a day and go home if you're in this state, or continue working. But this is the state you want to leave the status you want to leave in your work when you're calling it a day. Git log now shows the history of the repository. There's really just one because we've only made one commit so far. It's attached to my name and email. That's the reason I needed to config initially my username and my user email. And it tells me what happened. I added the README file. That's the message that I wrote there. Yes.
Why do you always want to be in main, like on branch main?
Oh, yeah, that's actually, I'm wrong that you don't necessarily want to be on branch main, but you do want to be on working tree clean ideally, because then you don't have things you need to resolve. But yeah, you don't necessarily need to be on main if you're still working on a branch and developing things. Okay. And so we'll start working with branches pretty quickly here. So this is very standard Git stuff. You add something to the repository, you make a commit with that addition. We can demonstrate that with one more operation. I'll open README in a text editor in the previous tutorial where we looked at this, we wrote this README file to describe a library and then added a license in there. And then maybe we will write something like how to install, and some instructions on how to install, clone the repository. We'll need to see what that means in just a second. Sorry, an issue. Python -m pip install. So now when I type git status, it tells me that there's some changes in this particular file. Those changes are not yet staged for commit. So if I type git commit -m right now, it will say, I don't know what you want from me because that's not staged for commit. Instead, the right sort of operation here is to first add the things that you want, the files that you want to add to this particular commit. And then okay, and so now we've added another set of changes, and we're back in this state. Okay, let's see what questions do people have so far. I've gone pretty quick here through initializing repository, adding a file in there, committing it, changing it, committing it again, git status along the way, git log. Yes.
So during this process, have we used the keyword generated, or is it already used?
No, we haven't used it yet. We're getting to that. So far, this Git repository is only in one place in the world, which is just on in my directory in the hub. But soon we will get it onto GitHub and start talking to GitHub, and that's when we'll need those keys. So that's why I wanted to do that first. Okay. In fact, let's go ahead and do that. GitHub.com, who here, let's say, uses GitHub on, say, a weekly basis, at least. Okay, several of you. Cool, okay. GitHub is a good place to collaborate with Git because it's got Git built into it. So it runs Git there. You run Git on your machine. They can talk to each other. It's very well configured, and you'll see it can automate a lot of your workflows for collaboration in a way that enables massive scale of collaboration, very rapid, very nice. Okay, so I'll create a new repository. If you go to github.com, you'll have this plus arrow at the top. Don't do that on your end. You'll be all using my repository as your sort of the root of your work. But I will create a repository, and then we'll practice later creating your own repositories, or maybe less if we don't get to it today. Next week, surely you will get to create those. And I will choose myself as an owner, and I can create one called GeoBlobs, and I'll make it public for now. Yeah, let's do our work in public, and I will initialize this as empty because sometimes you can initialize this with some additional components. When you initialize a repository, it says, should I add a README file? Should I add a git ignore file? We'll add those things on our side of things and then push them to GitHub. So we'll start this empty. And when we start an empty repository, it produces some instructions here for us to use that will let us upload, either create a new repository on the command line or push an existing repository from the command line. The first thing we need to do is we need to connect our repository on the hub with this repository on GitHub. Every Git repository on our machine has this notion of remotes. You can have many remotes, multiple different remotes. Remotes are other machines with which your local repository can talk. It can pull from those remotes or it can push to those remotes. In this case, we'll create this one remote. It will be called origin. And we're pointing to this git at github.com:ArielRokemGitLobs.git address is the address for this remote. And then we're going to use the other instructions here. We don't need to run git branch-m main because we're already on a branch called main. This would modify the name of the branch that we're using to main, but we've already done that. Instead, we're going to say git push -u origin main. So git push is the command that takes a repository that exists here and syncs it up with the remote. It pushes that state of the repository to this remote. It has, so git is the command, push is a subcommand, and it takes two arguments. Origin is the name of a remote, and main is the name of a branch. So you could do this without this -u. Git push origin main means take the main branch on this and then sync it up with one that's on the origin remote. And it's asking me whether I think that GitHub is worth trusting. And I say yes, and then it uses the SSH key. It adds, first of all, it adds GitHub to the known hosts on your machine. There's a list of the hosts that you trust, adds that there, and then it will push things into that repository. So now this one is synced up with our local repository. If we look at the history of commits here, it's identical to the history of commits that we have in the local version and the ones that's on the hub. And we can keep doing that. A little convenience is to do git push -u origin main, and that what that does is it sets origin, this other remote, as the upstream for this particular branch, such that if you're on this branch and issue git push, it knows that what you mean is git push origin main. I actually rarely do that myself, and that's just so that I have to think about where I'm pushing and what I'm pushing. It's good to slow yourself down before you do things. So I'm not going to do that, even though that's what GitHub writes there in that document that they provide. Okay, so far, now we've synced up our local repository with the remote repository. Let me do one more step here of operations of adding some more code in here and then pushing that up. Let me demonstrate how I will do that using a branch. Let's say that my project is now working. It's not, because it only has a single README file in it. But let's imagine for a second that this is a state of affairs that I'm happy with, and that I'm looking to make the next step in development of this project. It's good practice to never make changes on your main branch, and instead check out a new branch. And this one we'll call adds code. It's a good idea to create a new branch and then do your work on the separate branch until you're really ready to merge those. So I'm creating git checkout is the command that we use in order to switch between branches. If the branch that I'm trying to switch onto, adds code, doesn't exist yet, and I try to do that, Git would complain and say, I don't have this thing that you're trying to check out. But I can tell it, oh, if it doesn't exist, create a branch called this thing, and that will then switch to this new branch called adds code. And so the practice I'm trying to impart here to you is never to work on the main branch. Leave the main branch pristine, or leave it so that you're not ever doing work on that. When you're initially working on just setting up things, maybe you will, but in the long run, don't do that. And then what I'm going to do is I'm going to copy, well, I'm going to make a directory called geometry right here. And then I'm going to copy from this other directory called geometry into my geometry stopper, into my local geometry folder. This is a little confusing. In the previous tutorial that I created a folder in my home directory called geometry. There it is. And in that one, there's another folder called geometry. Geometry.eginfo also got created along the way, just to confuse us a little bit more. But in here is where the code is. There's some tests. There's an init file, there's a circle file, and I want to copy everything. So I'm going to do copy -r, which will recursively copy stuff into geometry. So now when I type git status right here, I have a new folder called geometry, and that has a variety of things. It also has this directory called __ PyCache, or I'll refer to this double underscore on both sides as dunder. So the dunder PyCache directory in there, we'll deal with that one in just a second. For now, let's add some code in here. So git add circle geometry circle.py git add geometry under init.py git add geometry tests, and let's add test circle. Git status. So this is pretty good. I've added some code. I've added a file with some tests. I've added a file with some geometric calculations for circles. I've added this dunder init file that defines geometry as a Python package. And that encompasses my code. In addition, it's pointing out that there are all these untracked files. These are all kinds of things that get generated along the way. These dunder PyCache directories are ways for Python to store. When you import some code, it stores, compiles the code into some intermediate representation. It can store there so that next time that you import this code, it goes a little faster. And we don't usually want to store those intermediate compilations. So we will now create here a file called gitignore before we move on. And gitignore is a place where we can tell it there are the following patterns in this repository. Please don't ever use those. Don't add those to my repository. I think if I do nano gitignore and I do PyCache and also .ipynb check points and save that and type git status again. I probably need to tell it more. Oh, I misspelled PyCache, and that's why I didn't notice that one. How about now? Right. So now it no longer complains that these are not being tracked because I told it to ignore those. It does say there's this one more file, the gitignore file, that also needs to be added here, and I will add that next. But let me do that on a separate commit because why not? So I can do git commit, all the things that are changes to be committed, things that I've already added. Git commit adds code files and tests. And then git add gitignore git commit -m. Maybe I won't do, just to show you, -m is a way to write the commit message right in line with the git commit command. But if I don't do that, what git naturally would do is to pop open the text editor that we configured initially as the core editor, and then I can write my message in here, adds gitignore file. And it's nice to do some of these things separately because this is topically very different. The reason I did this on 2 commits is the adding of the code, and the gitignore is, in terms of topic, is quite a different thing. It's more about maintenance of the repository. So I like to have those things separated in 2 commits. Yes.
How did you want to include the checkpoints in the gitignore? I wouldn't see that in the.
It was there. It's inside of one of these. I saw it show up in one of these. Here it is.
Oh, okay.
I saw that in the tests there was an ipynb checkpoints. If you ever end up running Jupyter inside any of these directories, Jupyter will almost immediately create these ipynb checkpoints folder. It's a hidden folder. It starts with a period, so you don't see it when you're working and you're on the command line. And it contains copies of checkpoint states of your Jupyter notebooks. And so if it gets included in Git, it can cause a big mess because you might end up with like some conflicts between different states of Jupyter notebook files stored in there. So putting that in the gitignore up front and early is a good idea.
Are there any other file types that you would suggest adding to Gitignore like that? I'd never heard of that.
Yeah, yes.
API keys like your Amazon.
Yes.
A postdoc in my life once had not done that, and it had been a private repo, and we made it public and didn't realize it was within like a day, somebody had spent $20,000 on our Amazon account. They gave us the money back after we figured it out.
And for similar reasons, if you ever use R and you are using R and tracking that, R creates an R history file that also, if you're entering API keys to Amazon, things that have happened to me, then it'll get stored in there. If that gets committed to GitHub, then yes, somebody will do something bad with it.
Yeah.
So yes, API keys, so secret information in general. And I will say there was a whole, and I won't go into that at all, there's like a whole separate universe of dealing with encrypted secrets that do need to go into GitHub, into repositories that you want to share, like you want some automated system to be able to get your secrets in order to run something for you. There's a whole world of encrypting things and decrypting them, but we won't get into that here.
Okay. Is there, like in line with that, do you have any cache files that might end up storing secret stuff or things that we wouldn't want released just even about our computer infrastructure or anything?
I'll say there might be things like that. I think the most safe practice to do is to almost never use git add star on anything.
Okay.
Like on any directory, git add star is a danger. Adding files one by one is good practice. And then if you see, oh, this file, I don't know what this file is, you want to maybe explore that. I just track things very intentionally and ignore them judiciously.
Thank you.
Okay, so far we've been working on the separate branch. So if we're looking at our file system, and there's geoblobs, which is where our repository is, there's a folder here called geometry. It's got tests in it. It's got all these useful things that are our code. If we now check out the main branch, and refresh this view here, you'll see that. Why is geometry still here? And that's tricky. Oh, interesting. For some reason, it's still retaining. I'm baffled, but I'm not sure why it's keeping this geometry. There's something there that. So first of all, git branch -a will tell us which branches there are in this repository. It tells us that we're on main. That's why the star is next to the main. It tells us there's this adds code branch here as well. And then it tells us about the remote branch that we set up that we have a relationship with, which is on GitHub. And the reason I'm slightly baffled here is that I expected that when I go between adds code and main, that this geometry folder would disappear. Because it's only added on in one branch, it's not added in the other, but for some reason it holds on to it even when we switch over to main, but there's not as much stuff there. There's basically just the directories. Sorry, when I switch to main, I would have expected geometry to disappear out of here. It's not, because reasons that I don't understand, but they're not too important either. So here on main, git log contains the addition of README, the installation instructions in README. But if I git checkout adds code and git log in here, you'll see that there is more to it. There's the addition of the code files and tests and the Gitignore file. So these histories are slightly diverge, or rather this history is a little longer, contains more than the history on main. Now let's say that we are perfectly happy with the code that we have there, the code and the tests that we've added. This adds useful functionality, and we're just perfectly happy with that. We could go ahead and issue git checkout main, and then git merge adds code. This would switch into main, which we've done, and then git merge adds code would then add the subsequent code into this branch. But let's not do that. Let's instead go and git checkout adds code and make life a little bit more interesting by pushing origin adds code. So again, git push origin establishes the relationship between the repository that we have on the hub where we're working right now, and this remote, which is the origin remote, which is the stuff that is up here on GitHub. And GitHub helpfully tells us that we've pushed a different branch in here. In fact, we can switch between those branches using the GitHub user interface. There is the main branch. Here's this adds code branch that adds the additional code. So I can, on GitHub itself, I can see the different states of the repository and I can compare them between them. I'll do that in just a second. But let me actually pause here for a second. I've done a bunch of things here and I want to see what questions people have at this point. It's a bunch of complicated operations possible. Yes.
Is there a naming convention for the branches? So I'm most familiar with, like, say, dev, feature, and main branches. Like, I'm not sure if it's used in the naming.
Yeah, the question is whether there are conventions for how to name branches. And possibly if I was a better person, I'd be following a more strict convention. I don't really. I have this kind of, I tend to think of branches as short-lived and ephemeral in nature. But it's not a bad idea. One thing that I've seen a lot of that I don't like, so I'll just say it, is slashes in branch names. And that's because slashes have actually a special meaning. And if you looked at the, here you'll see that there are slashes in branch names, but those are slashes where those slashes mean something. We're like looking at a particular remote, a particular. So this for me, I don't like slashes in branch names, although people do dev slash, some feature dev slash, and Git will let you do that. And then you'll have more slashes in here that don't exactly mean what this means. So that confuses me. And I prefer dev dash something. But yeah, having conventions for what the branches are about is not a bad idea. Yes.
So now that you push adds code to GitHub, are adds code and origin adds code two separate branches, or if you push the adds code, will that also push to GitHub?
So it gets complicated because somebody else could be pushing to this branch here, and then those two will be different from each other. And that complicates matters. That's why we need those two markers to tell us we could be checking out that one or this one, and those might change at the same time. But we'll rarely have to sort of make that distinction. It's only rarely that you have to sort of say, oh, I want to check out that particular one, not that one. So I'm not even sure under what circumstances exactly, except some real complication that's happened. Yes.
Yeah, I just got this message from GitHub that says that my main branch isn't protected.
Yes.
Do you know what that is?
Yes. So if you create a repository, GitHub provides all kinds of technical kind of widgets for you to work with your repository. We'll see things like adding collaborators in just a second. But also it allows you to say, all right, I told you never to work on main, right? You don't want to work on main. You want that branch to be this branch that you know that it works. You can add another layer of protection to that by calling that protected. And basically, I think what that prohibits you is from ever pushing into main. If you try to push anything to main, it'll say, no, you can't do that. And the only way that code could get into main is through an orderly process of code review, which is what I'll show you in just a minute here. So those of you regularly working with Git and GitHub might have already seen one of the modes in which you can work with Git and GitHub, and I do that all the time, is I'm the only person using this repository. This repository is for my own work on some project. Maybe it's like, this will be pretty typical if I'm writing like slides for a talk and I'm using GitHub as like backup for my slides, or as Russ does, for example, to use GitHub as a way to display your slides, because it can serve a website that has the slides. Those slides that Russ was using have that GitHub URL because the slides are there. And so in that case, I'm pretty much just working by myself with these slides, and then I'll use the main branch and I'll just push the main branch and never have to pull really because nobody else is pushing in there. Just working by myself. This is my backup, or maybe this is the place where I'm serving this up as a website, something like that. So that's one mode that you work in using Git and GitHub as sort of like a backup and tracking mechanism, and possibly a mechanism to share some content with other people, but without explicitly collaborating with other people. Other people are not going to be changing that. In that case, it makes sense to work with a single branch and keep pushing in there. Maybe after it gets a little bit elaborate and you want to try out things, maybe you'll create separate branches and make experiments on those branches, possible. Or tag certain states of the repositories to say, this is the talk that I gave on this date in this place, and this will be this version of the talk at some other place, so that I can switch between those. But if you're starting to collaborate with others, now you need to sort of make a more orderly way for people to see when the state of the repository changed. One way that you could do collaboration with others is that you can implement collaboration with others is to add other people as collaborators through the settings of the GitHub repository and say, this person is also allowed to push into the same repository. And maybe they're allowed to push into the main branch or into other branches, but they're also allowed to push. That's one way to collaborate with people. Let's just show of hands, who's used that kind of functionality in GitHub, sorry, where you're working with other people and everybody is pushing to the same repository. And then I'll demonstrate that here. We'll try a little demonstration here. So let's say that I'm collaborating with another person. Two-factor authentication, so I'll do that using my phone. Okay, and I can add people to this repository. The way that I add people, go to the settings, to this collaborators tab, and then I can add people. Let's see, who should I add? Someone share your GitHub username here, and I will add you as a collaborator and go from there. Several of you are, that's good. I like the several people are typing here. Okay, so Max. Okay, your laundry. Oh, add people, sorry. There you go. Okay, I've added a couple of collaborators here. This will get interesting. It's writing here pending invite. That means that when I add a collaborator, GitHub wants to make sure that I'm not just spamming someone with an unintended collaboration. Instead, it sends an email to that other person and says, hey, Ariel sent you an email or added you to this. Would you accept this invitation? And then once Landry or Max will reply to this, then that will change. I'll try to refresh here just to see. Yes. Okay. So Max is already a collaborator, and let's try have Max make some changes here. This will get interesting. So what I'm going to ask you, and we'll see how things can go wrong. I'll show you how things go wrong when you do this, and then we'll use a different mode, and that'll be less wrong, slightly less wrong. Always aiming to be slightly less wrong. So Max, are you able to clone the repository?
Give me 1 second. I'll give it a try.
You sounded very robotic over here. If you copy this Git URL here, then you should be able to go to your terminal here and say in your home directory, issue git clone. And that address, and actually anyone is able to do this. The GitHub repository is publicly viewable, so anyone of you your home directory and get a copy of GeoBlobs. In fact, go ahead and do collaborate on GeoBlobs together. And hopefully Max will let us know when he's ready to. Okay, he's successfully cloned the repo. Now go and edit something in the README file in the main branch and commit that and push that to the main branch on GitHub. So that'll be something like you go in there, you would CD into GeoBlobs. You would open README with a text editor, and then you can edit maybe this line to say something. A library of Python functions for geometrical calculations and such, or add your own addition there. So let's make your addition different from my addition so that it becomes interesting. And so that we can demonstrate why we need. Okay, got it. Let me see if you push that to main. Now, after you make the change, you will want to issue a git commit -m some message, right? The message that says what you did, and then git push origin main. And because I approved Max as a collaborator, he should be able to do git push origin main. Others who have not been approved as collaborators can still clone it because it's visible publicly, but you shouldn't be able to push into that repository. Okay, push to main. Okay, so now there's a change. I'll just refresh this to see this change. And you can see that now Max has added a change to the README. Right, okay. So he's added a line to the README, and you can see it right there. And so I'm going to try to demonstrate why that can go wrong. Let's see if I can do that. In fact, I'm going to take his exact line, and this is not a usual situation, but you can imagine a situation where we're both working on the same repository, and we've just introduced the same line of code, but mine is slightly different from his. So imagine that we do that. And I want to check out the main branch because we want to be working on exactly the same branch on the same line of code at the same time and doing different things. And you'll see why that can cause mayhem. So I'll add README and then git commit -m changes the same line. Now, when I try to push that, it will send this ominous message, which is to say, the remote contains work that you do not have locally. So you'll often see this kind of message that means that the branch that you're working with on the remote has changed while you were working. Usually the solution to that is to first issue a git pull origin main, which would then pull in the changes and merge them into your local local copy. But in this case, we have divergent branches, and that was interesting. I didn't manage to get a conflict going. Instead, it's asking me how I would like to reconcile these kinds of situations. And I can say, this is again a configuration thing, and I'm going to say, you know what, only merge this if it's truly what's called a fast forward commit. This is the most kind of conservative way to go about this. If this really is a fast forward, there's like a really clear relationship between the commits, then allow a merge in. Otherwise, abort. Let's try the merge instead. let's see what the situation is here. Ooh, it refused to merge for me. That's unfortunate. Woo! Branch mean. Okay, that was unexpected. Sorry about that. Let's try the true here. Oh, I want a global config for that, right? Let's try that. I'm not even sure what to do here. So I'm gonna abort this line of reasoning, and we'll figure this out later.
I have a question for you.
Yeah.
How often do you end up just completely killing the Git folder and starting over from scratch because something like this happened?
Not that often,
But
not impossible to imagine. Yeah, it's not once it's on GitHub, it's very easy, right? You nuke the thing and copy it. That's one of the reasons to use GitHub is you have a copy of the whole thing and its whole history up there. And you can, I try to avoid having something really important that's only on my machine, the state of the repository on my machine. That would be unhealthy. And even if I have additional branches, I can push those and then I can fetch those from GitHub. So it does happen that I look at something Git is, it's all relatively new things. I'll justify myself by saying these are all relatively new features of Git about these, how exactly to merge things that totally threw me off here. Git is a complicated machine, as you'll learn yourself. So often you need to figure out how to get around its complexities. I will say, okay, so we're trying to work on the same branch. We've gotten into the situation. We can avoid those kinds of situations where we end up with this thing. I was hoping for a real conflict where Git would tell me, oh, you had this version, that we would have to resolve this conflict. But instead, let's work in a less conflictual situation where we just never work on main. And instead go to the other thing that I was hoping to show you, which is that I have this branch that had recent pushes to it that adds additional things into the repository. And in that case, nobody ever pushes anything to main. Instead, the way that we get things into main is through what's called a pull request. So raise your hand if you've used pull requests before. Okay, some of you have. Okay, great. The idea behind the pull request is that it's specified up there on the bar here. It specifies that you would like to add, basically you'd like to merge two branches, but instead of doing that on your machine, as I showed you before, git merge adds code, git checkout main, git add merge adds code, you'd like to do that in GitHub. So when I create this pull request, everyone designated as a collaborator on this repository would get an email saying, hey, Ariel wants to go and add this code here or make the following changes. And then everyone can go to this page. Everyone who's a collaborator can go to this page, look at the files that have changed and make comments here. Like, I don't know. Why do you need so much white space at the end of this file. Right? If I click start review, it will add this comment to a pending stack of comments. And I can add more comments to that pending stack, like saying, this sentence needs a period at its end. In fact, the interface allows you to propose changes to the code. So if you click on this button here, it will open up this kind of dialog that says this is a suggestion. And so then the suggestion can be added to the comment. So when I add a review comment, it adds the suggestion right there of like, this is how I would change this line. And this all gets added to a stack of comments. And then when you're done reviewing all the code, looking at everything, this probably needs to be removed. And then when adding that also as a suggestion, will let me add a removal as a suggestion. Let's see. Yeah, right. Once I'm done reviewing all the code, I can go and I can finish my review and, request changes. I'm the pull request author, so it doesn't let me say that I'm requesting changes. Can't even approve this. I can just comment, okay? But other reviewers can go in and add comments and then request changes, and then there will be sort of a process for me to add these changes where I can add another comment. I'm self-reviewing this as a demonstration. Whoops. And then submit that review. And once I submit that review, then it all goes into all of the things that were pending will go into this. There'll be at the top, this comment that I wrote last in this panel will appear at the top. This might be a place where I would write sort of top level, big picture comments on the code. And then these are detailed line by line reviews. Very helpful to have both of those things when you're reviewing code, both sort of top level, this is good, this is, maybe you might add this other functionality. This is how it integrates with other things we're working on. And then line by line to say, this is how I would implement this thing. Have you thought about this? Have you thought about that? So all this, if somebody else is reviewing, all this shows up in my inbox as an email. And I can go and read that in the email. In fact, I can reply in my email. And that goes up here. A nice thing about this interface, one of the nice things about this interface is it facilitates an asynchronous mode of collaboration. I go in and I submit my code. Somebody else shows up whenever they're ready to work on this and makes their comments. That gets sent to me. I can reply to these. I can make changes. I can make more commits on the same branch. And that will also go into the pull request. And also the fact that it stores all of these comments in perpetuity together with the code. So the repo contains a history of not only the code, but also the changes that were made to the code and the discussions that happened when changes were made. So you can go back and look, we changed this code in this pull request 2 years ago. Why did we do that? What were the pros and the cons? What did other people say? And go and look back at that discussion. So that's very helpful as an archive record of all the changes in the repository. Yes.
So let's say there's a repo, I'm collaborating with someone, I clone it and I make my own branch and this other person has their own branch. So that's really good. Let's say I work on my branch for 3 months. I never pull, I update it, and then I want to push it back to me. Sorry, I don't have the verbiage quite yet.
Yeah, so how do things get integrated into your copy on your machine ultimately, right? That's sort of the question.
Well, I think the question is if someone else has been pushing and pushing and pushing back to the main. And so eventually it's not only the changes that I've made that are different, it's also different because the other person has actually been pushing back to me. And
Yeah. So this, if you're working on large collaboration, many people will be issuing these pull requests on multiple different features. You're working on something on some branch. Meanwhile, main is moved ahead because the next thing that will happen, I'll just go ahead and do that first and I'll answer your question in a minute. The next thing that can happen is maybe I'm happy with all the changes. Maybe this can go on for a while, this review back and forth. I might say, yes, let's commit this suggestion. So that gets committed automatically over there. Commit this suggestion too. And then, we have a back and forth and discussion about all these changes. And eventually we're all happy. And maybe I don't make these changes. Eventually, we merge this pull request. Now somebody else comes in and makes another pull request, right? And that also gets merged into main. Eventually, we'll want to be able to go in here and do, so now I should be able to do git pull origin main. Right, and now now it added these small updates. These two commits are the commits that I made on GitHub. Remember, I made comments and I suggested things and I clicked on commit suggestion. These commits are those commits. These GitHub has its generic commit message, and that one is the merge of the pull request. Right. So now my copy of the main branch is in sync with the upstream. But let's say that I had another branch here. Check out -b, another branch. So now I'm going to work on something else. And you're asking, in the meanwhile, main has moved ahead and I'm working on this branch. How do I make sure that things are in sync?
Especially if you're editing like the same code or like.
Yeah.
With similar, like, files.
Yeah, so to clarify, just also to emphasize the importance of the pull request, is that when you're working with pull requests, it's the code will not get merged into the main until it's ready, right? If there are conflicts, for example, that's up to the author of the pull request to resolve. If there are any conflicts between the pull request and the main branch, right? And you can't merge that until those are resolved. And I'll show another case where it's up to the author to sort of fix things in just a second here. And the question is, how do we reconcile that? So one thing that you can do is keep checking out the main branch, pulling the main branch, the updates to the main branch, and then merging the main branch into your branch. And then when you're merging, that's when the conflicts will arise on your branch, and you'll have to resolve those on your branch. That's the simpler way of doing that. A more advanced way of doing that is called rebasing. And that is what Git does in the case where you do a Git rebase, is it edits the history of the repository to pretend as though the branch was made from the current state of main. It takes, you can imagine the repository, the history of the repository being commit, 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 like a graph. And then your branch is a branch off to a separate thing. Let's pretend that we disconnected the graph here and we reattached it over here. So you can do that kind of editing of the graph that Git generates as it's generating its history.
Do you get to,
Yes.
do you get to be specific about like how the rebase works?
Yes, to some degree. If there's conflicts, it'll be up to you in order to complete the rebase to edit the files where there are conflicts in a way that is to your liking. Generally, conflicts arise when different people edit the same file. I tried to generate a conflict there. And the solution to that is almost always to edit the file by yourself and set it to be the state that you want, and then resolve that when things need to be merged eventually. Let me make one more step here just to show you one more cool thing with Git and GitHub. Yes. Oh, there's a question on Slack. Can you see my face anymore? Maybe. The owl sometimes wanders. Is there any way to know if the changes from the pull request will work without checking the changes line by line? Yes, so that's the thing I'm going to show now is how do we make GitHub check the code for us in a very particular kind of way, which is to say in the code that we implemented here, one of the nice things about this project.
Okay, great, thank you.
Not to put too fine a point on it, is it's got tests, it's got automated testing. And wouldn't it be nice if GitHub, so one way I'm making some changes, this is kind of the traditional way. I'm making some changes, I'm making a new pull request, and I change the functionality in some way. And you as a reviewer look at this and you're like, well, I'm not sure, does this work? Doesn't it work? Let me pull down these changes onto my machine and run the test suite. That would be a reasonable thing to do. Does it break the tests? But that's onerous. Now you have to download the code and run the tests, and you're lazy, you don't really want to do that. So you just look at it and sort of eyeball it and think, oh, maybe it passes, maybe it doesn't. Wouldn't it be nice if GitHub ran the tests for us and told us whether they pass or not? So GitHub does that. Let's see if I can make that happen here really quickly. Well, maybe not that quickly. Okay, so there's a thing called GitHub Actions. This falls under the broad bucket of something called continuous integration. It is, yeah, we want to integrate our changes continuously into the code and seamlessly and automatically check whether the code works. So we can do publish, no, not publish, Python package. So there's a variety of pre-canned actions. you can get started with actions by going to actions and then typing configure here. And what that will do is it will create a new file in your repository, create a new directory called .github. Inside of that, it'll create another directory called workflows. And in there, it will create a YAML file called python package.yaml. And it's doing that in this case, it's doing it on the main branch. And this file is slightly complicated. It's got a set of instructions for the Python versions that we want to test, the conditions under which we will want to test this. And then it has some instructions for what to do when we run the continuous integration. So the thing it will do up here is it will upgrade the pip, the installation of pip that we have. That's the Python package manager. Then it will install some additional things, and we'll install something called Flake 8 that will check our code for compliance with PEP 8 and other kind of linting. We'll install PyTest, which is what the software that we're using for testing. And then if there is a requirements file, it will install the requirements. Gonna check some things, and then it'll try to test with PyTest. Let's see if it works. Let me commit that here and here. And then we'll iterate. So this creates this file, and I'm committing it straight to main branch. When I did that, did it start running? No, it hasn't started. So in order to kick this into action, now that it's on the main branch, I need to make another pull request, and then we'll test the other pull request. Oh, it did kick into action. There you go. One of the conditions under which this runs is when I push it into main. So there it is. So now it's building on 3 different separate, and it failed pretty quickly because I didn't really look very carefully, but we'll see what happened. That'll be interesting. It starts 3 different machines there. Inside each one of these is a build. These steps in the build correspond to the steps that were that YAML file, and it fails pretty quickly, and that's because there's no installation step of our software. And so we'll need to go in there and change that so that it installs our software. Let's try to do that. So I'm going to git checkout. So I have this other branch here. We'll come back to that one, but git checkout main, git pull origin main will now pull in this configuration file. This thing now, okay. Why did it let me? It let me pull over here, but then now it doesn't let me pull. That's interesting. We'll try a bunch of stuff, as they say. Oh, good. Okay, I got the conflict finally. Thank you. So I tried to merge. That was from origin. Remember the one that had origin slash. Here's a conflict. So these are conflict markers that Git introduces into files when there is a conflict between 2 different states. One is the state that Max introduced, this one down here. And this is the state that I had edited. We both edited the same line. That's why we got a mess. And that's when multiple people are pushing into origin. This is the kind of mess you could get. Okay, I'm going to edit that to my satisfaction, and then git status. Now there's these new files that came from the changes on main, and then there's this unmerged path, git add readme.md, and then git commit. And it's going to introduce an automatically generated commit message here that's all about merging between things that were unmerged before. And now I have in here, I have this GitHub folder, and if I do nano.github workflows Python package, I will get this file that has the configuration for this continuous integration. I will add in here, instead of this pip install requirements, I will add python-n pip install dot, which will install, hopefully it will install the software. Okay. Git add.github workflows, Python package, git commit -m, fixes CI. It's optimistic. Was I in main? Yes, I'm on main. Bad idea. Git checkout another branch. Let's work on this other branch. Git push origin another branch. Okay, so I created that, and it actually gives me a URL here that if I click on, it will take me to where I can. That's interesting. Ooh, the owl is not connected. Sorry. Yeah. Can you all see me anyway? No, because my camera's on. Hang on, let me fix that. Okay, it's back. Share the screen again. Okay, another branch. Did I forget to push another branch? I'm going to make another edit here just to make sure that there are changes. Oh, this file doesn't exist here. Oh, I think I know what happened. Doesn't exist. Okay, I'm gonna close this terminal. I made a little mess there, but I think the problem is that I made the commit adding this this continuous integration stuff on main, not on another branch. So now I'm going to merge main into this one. And now I'm going to push origin another branch. Such that now having done that and comparing that to that, I now do have some additional changes in here. Okay. So now when I create the pull request, which presumably fixes CI, what it'll do is it will although it doesn't, should start the actions. Okay, I had some failure, but it couldn't show that. Ooh, this gets a bit finicky. It should be running in there. Let me make another change here just to make sure.
This is not an error in your account.
Oh, there could be some malformed YAML code. It's always fun. Line 28, there is a problem. Oops. These were line numbers in this text editor, would have been nice.
Maybe installing geometry.
I'm going to remove the file that I created, and it's possible that,
Oh, the space.
yeah, it's a space versus tab thing.
Oh.
git add this thing. Okay, let's see if that worked. So for some reason it's not, well, now it is running it because the YAML was fixed. So now it's running it in the pull request. So this is the important part here. The important part is now the pull request itself is running this continuous integration. It should, if everything went well, it should be installing the software onto some machine, somebody else's machine, right? GitHub's machine in this case, somewhere in the cloud, from scratch. And that's also nice. It doesn't depend on this working on my machine. It depends on it working on some new machine that doesn't have anything on it to begin with. So everything needs to be specified. And then if everything goes well, and it didn't, then it should install that and then run all of the tests as well. It failed on, right, I didn't put the setup.py file in there, so that's why it's not installing it. But assuming the setup.py file was in there, it would have instructions for how to install this code, and then it would have additional instructions within that same file, within that same configuration file here, about all the steps that it needs to take. Now, important to note is that when it says run in here, in one of these steps, each step has a name. And when it says run, this stuff is running in bash. And anything you could run in a bash shell, you could run there. In this case, it's running some linting, it's running some testing, but you can imagine running very complicated, writing some shell scripts, or running some very complicated shell scripts. There's a whole ecosystem of these actions out there already. So you'd rarely start sort of from scratch here. You'd be starting with a lot of other help from others. You could do really, really complicated things like creating entire websites and uploading them, interacting with other complicated systems like our Jupyter Hub, for example. The way that the dependencies are installed into our Jupyter Hub is through a repository that has a GitHub action that builds a Docker container that has all the dependencies in it, and then uploading that to a particular system that we can point to and say, this version of this image is the one that's currently running on Jupyter. So you can build these really complicated integrated systems that are all automated through this kind of through Git and GitHub. And this, at least for code review, this just sets a totally different baseline for where you start working on code review. Instead of downloading somebody else's code, checking that the tests work, and you can point them and say, look, this test failed. Why is it failing? Is that a good thing? Is that a bad thing? Fix all your tests, fix the linting, right? Write it so that a linter that checks that the code is up to standard is happy. And then I will review your code and integrate it into my project. So that's the kind of magic of this system. And again, you can do really complicated, cool things with this. I've seen people do automated data analysis, right? Every time you change something, it runs a set of notebooks that do data analysis on some data somewhere, downloads data from somewhere, does the data analysis, and then presents those notebooks somewhere. Yeah.
Does it do it on their computers or like their machines?
It does this, yes, on GitHub's machines.
So they can do data analysis on GitHub's machines? Yeah,
Up to a point. After some memory limit and time limit, it will ask you to pay for your compute time. It's not, they're still not a philanthropy.
I actually did have a question about like privacy of
Yeah.
code and like when you're running these things on GitHub's machines. And
Yeah.
like, do you know anything about like privacy or like what this code can be used for if it's being used to train models or anything like that?
Oh, how they're using this. Well, obviously they are training models on all of this code because, as you'll see in a short bit,
Okay.
the GitHub are the ones who've implemented one of the leading solutions for like AI-based programming called Copilot.
Okay.
It's trained on GitHub. What else would it be trained on? It's not clear whether it's trained on private repositories, though. I'm not sure what the status of that is. And the copyright questions are,
I'll be saying more about those.
Yeah. So, but I will say you can get, if your code is private, you need it to be private for some reason. you can get machines that work in private and nobody else can. I think you'll have to pay for that level of service. So as long as you're out in the open, no problem. You'll get free compute from them. But once you want private stuff, you need to pay.
So I don't really, you were saying earlier, ways to encrypt.
Yeah. There's,
Would that work in terms of testing and stuff like that?
yeah, I think you'll always need somewhere something will need to be privately held, right? So that the decryption keys are sort of privately held. But there are ways to set up systems that are pretty secure. But something will always need to be held private, right? To kind of just don't make everything public. Okay. We're at time here. Hopefully we'll get to play a lot more with this next week. Because hopefully you'll want to sort of build things on top of these GitHub actions, and I'll be around to help set these up. In the meanwhile, if there are remaining questions on GitHub and so on, just put them in Slack, and we'll take a half-hour break now, and then we'll reconvene in the Alder auditorium.